If you're speaking, Professor, I can't hear you.
Hello? Can you hear me? Oh, I heard something. Sam, can you hear me?
I can hear you.
Okay. I see you, hear you, and Mr. Cooper, I do not even see your microphone moving.
Yeah, it's on. I don't know what's going on here.
Now we hear you.
Oh, you can?
Yep.
Yes, sir,
Oh,
just then.
God, what a nightmare. I mean, I had to take my brand new MacBook into uh, GCEIT, and I have no idea what they did to this thing. But anyway, the computer's clean, so that's all I care about. Okay, can both of you see the screen?
Yes.
Yep.
Okay. So what I've done is in the announcement, the document that I talked about last night that has definitions and keywords is loaded. I'm not going to go through reading that. You guys can read that and make sure you have it open when you take the final exam. What I am going to do is go through this problem that I've created. I'm going to go through it step by step, and each one of your linear programming problems using integers will follow a similar format. Now, I am working on a couple of the homework problems in the same fashion that I have what you have on the screen, so that you'll have a template to do all of the homework problems once you understand how we do these step by step. Does that make sense?
Yes,
Hello?
sir, and appreciate
Oh,
it because
okay.
that
Okay.
hasn't been
So
fun.
I don't want to keep you any longer than necessary. By the way, this call is cleared by the university so that it meets um, academic requirements for participation, um, because they are aware of what happened. All right. So the first thing that we'll start with is we'll start with the problem. Now, this problem is simplified, and uh, I, I'll read it, and I'm going to read it for one purpose. I want you to read it in much the way that I'm reading it, so that you start to see where the parts and pieces are and why those parts and pieces are important to the question. So, a machine is used to produce two interchangeable parts. That's a very important element. Two interchangeable parts, one machine. So we know automatically that we have an either or. We have a 0 or a 1. We have an on or off because we've got two interchangeable products, but we only have one machine. If we had two machines, we wouldn't need an integer linear programming solution to determine which one was best. We could simply use linear programming to get to what the maximum production of each one of these should be if we had two machines. But we don't have two, we have one. Now, the daily capacity of the machine that the machine can produce for product one is 20 units of product two. Can you guys still hear me?
Started cutting it in and out.
Uh, okay, I'm going to keep going. Can you get something anyway?
You're really going in and out pretty good,
What
sir.
the heck is? Okay, can you guys hear me now?
Yes, sir.
Okay, so I'm going to go faster. And this is, I think I'm connected to my iPhone. And I'll bring it up closer. Is this better if I have it closer?
It's working at least.
Okay.
Yeah.
All right. So we stopped off where we were making a decision, because this is the key to why we use integer linear programming as opposed to the same linear programming solutions we've been using before. If we had a problem where we had multiple uh, decisions to make based on multiple criteria and multiple constraints, this is where linear programming using an integer solution really helps. So, as I said at first, the machine can produce two interchangeable products. We have a daily capacity for one product, and it produces 20 units. We have a daily capacity of 10 units for the second product. But remember, we only have one machine. Now, we're going to introduce something else into this problem, which is demand. Now, The machine can be adjusted so that we can produce 12 units of product one and 25 units of product two every day. That is the maximum adjustment that we can make to this machine. And remember, we only have one machine, but we have two products. And to add a third constraint to this, we have a demand. So the market analysis shows us that the demand for the two products combined is 35 units. When we see something like that, that automatically tells us that that is a constraint. Okay? Now, given that we have a financial interest in the production of these units, we also need to know what is the respective number of units for the two products and the cost or the value of it. So that's where we have a $10 and a $12. This is why we have integer linear programming. So to start off, we're going to do this exactly like we would any other type of linear programming. We're going to identify product one as x1, product two as x2. Now, y is going to equal 1. It's one of those constraints that we have that we haven't had to deal with before, because we're going to have to process x1 and x2 separately and then together. So y is a 1 if the first setting is selected. Otherwise, it's 0. It doesn't count. So when we start to formulate the problem, I'm going to go now from here. This is the actual calculation on this Excel spreadsheet. This is the calculation of what we're about to talk about. So I need you to switch your vision over to the Zoom problem solutions and explanation for 660 ILP. Here we have the objective function, which is profit equals 10 times x1 and 10 times x2, which we can see in the problem, 10 units of x2, 20 units of x2 and 10 units of 20 units of x1 and 10 units of x2. Now, when we get to the profit, we have a value in here that I think may cause some confusion. And that value is 12. Because when we start to go through the process, we see that x1 is greater than or equal to 20, x2 is greater than or equal to 10. x1 in the machine setting 2 is greater than or equal to 12, and x2 is greater than or equal to 5. So I don't want anybody to get off track. We're going to get to that and why that 12 and 25 are there and how that's calculated. Our market constraint for demand is 35 units. So x1 plus x2 is greater than or equal to 35. And of course, because we're producing something, we have a non-negativity constraint, x1 and x2. Both have to be greater than or equal to 0. So to do our calculation, we start off, we want to maximize 10 times x1 and 12 times x2. Now, x1 is greater than 20, greater than or equal to 20. x2 is greater than or equal to 10, meaning that x1 and x2 have to be greater than or equal to 35. There's our non-negativity constraints, and we go to machine 2 and do the same step. Now, this is where we will start to explain why we're using 12 and 25. Everything that we've done so far, we've done in every problem that we've looked at in linear programming. So all of these things should be familiar. This x1 and x2 greater than or equal to 12, greater than or equal to 25 is probably what would cause some confusion. But we'll see that it makes perfect sense, because with machine 2, the maximum value for x1 is 12. Why is the maximum value for x1 12? Because if we look here, the machine can be adjusted to produce 12 units of product 1 and 25 units of product 2. That's where the 12 and 25 come from. So now we have all of the elements we need to calculate this problem. And I think, again, people might have been confused and lost with this 12 and 25, but that's in the problem. It's in the word problem. And we have to make sure, one of the things I think is important is to make sure that when you read the problem, you write down all the numbers, everything that has a number. And if you do that, when you go to solve your problem or put it in the form of an equation, what you'll find is that you're missing something, and you'll know you're missing something, and then you can figure out where it goes or what it pertains to. So to get to solving the problem, we would take our profit equals 10 times 12 plus 12 times 23, which is 120 plus 276, which gives us a total of 396. So comparing the value after, because we do the same thing for the other part of the problem, comparing those two maximum profits, we could see that we should take the machine setting number 2 because it gives us the greater profit, 396 versus 320. Now, the first product or setting for the product that we had was 20 and 10. Well, we know that that only produces $320 in profit. But when we set the machine at setting 2, which is 12 units of product 1 and 25 units of product 2, and that number 1, that does two things. It satisfies the constraint for 35 units, which is the demand maximum. We don't want to produce any more than 35 units of both products combined because we would have waste. So we don't want to waste. We want to maximize our profit by not having to subtract waste out of that. So the machine setting 2 provides higher prices, a higher profit, and it meets all of the constraints for both machines, and we can look at the profit settings. Now, let's suppose for some reason someone said, oh, well, we want to make 320. Well, then that wouldn't be a maximization problem. So the differences between what we're doing in this topic and in all the other linear programming is that we can input multiple constraints. Now, there are some programs like Jerobi and Solver is one. It's not as sophisticated, or it doesn't satisfy large range problems like Jerobi because it doesn't have the machine computing power or the capacity to accept the number of constraints that some of these standalone information systems have. These types of problems are used in business in many, many instances where there are multiple constraints and multiple combinations of products that we want to look at. Remember, when we started with linear programming in topic 3, everything was pretty simple. It was pretty straightforward. We identified what we wanted to get to, and we had 1 or 2 constraints, and that was it. And that's a very good introduction explanation. But this is the bigger wheelhouse that you want to use in business, because you can actually take many problems, use the same format, as long as you identify your constraints and the relationship between those constraints, you'll be able to solve which of those are the better decisions, because that's what we're all about, is making better decisions. Okay, so now that I've done that, I am going to open the floor for questions.
Is the 25 units a typo? Because in the paper problem solution, you have 23 in some places and 25 in other.
Oh, well, maybe I mistyped those in a hurry. Okay, so yeah,
That's
that
23.
should be a 25.
So
But if it's the 35 minus 12 right there, then it is 23.
Oh, no, Sam, she's right.
no, I'm saying the 25 in the problem in the question, the original, is that supposed to be
Well,
20?
it has to be 25 because product 2, no, you're right. Sam, you're right. And Christina,
You were not.
I'm
Because
cool with
the
that.
maximum demand is 35. So Sam, you're right.
And then the same for the constraints, because you have in the constraints below.
Yeah, it's gonna be 25, 23, and 12. Correct.
Okay. And so you were giving us an example for the
What's
X2,
that?
and that's the reason why.
I
For
couldn't hear you.
the red
Well,
23.
Well, when I started this problem, I started off with 25. I've redone it a couple of times for simplicity's sake and trying to write it out. And Sam's right. He caught it. I'm glad he caught it because it is 23 and 12. Because when we adjust the machine for the second run, second type of run, we can get 12 units of product one and 23 units of product two. That's the only way that we can also satisfy the constraint of 35 units.
And so the first machine setting just doesn't make 35, it's just making 30. Like
Yeah.
there's no way for me. Okay. And then one other question is, could you explain creating the constraint for the x1 minus 8y, with the
Well,
demand?
that 8y comes from the 12. 8y is, where are we in the problem?
The demand is 35.
hmm
So that's obviously correlated to y.
So I made a mistake here, Sam, because that 8y and 12 don't equal 25.
Is that how it goes?
Yeah. But I tell you what, if everybody followed along with this, I will go through my example and re-upload this once I correct it, because what you came up with creates a lot of confusion. So I'll correct this in just a few minutes and post this back up on Halo.
Okay.
But for the most part, is everybody kind of okay with the process? Why we're doing this versus doing what we've been doing for 2 weeks?
I believe so. I just want, making sure so that 18 should be it's 23 instead of 25 because it's 35 minus 12 is 23, which it goes up to the same thing up there. And that 8y, which is that 20 minus 35.
Yeah, this is where
Okay.
Christina, I've got to go back and do the math myself. Can you see where my cursor is?
Yes, sir. I was
No.
just putting it in my head like Sam had. Sam had the same questions I had.
Yeah, okay. If you can give me a few minutes, I'll post that and repost this document with the corrected constraints.
Okay.
And I will post the link for this as soon as I've made those corrections. I won't post this link with the this incorrect constraint. Okay? Hello?
Copy that.
Roger.
Zoe?
Yep, got it.
Kelly? Okay, well, she'll
Got it.
watch the
I found the
recording.
unmute button. Yeah, got it.
Okay, so give me about 10 minutes to make this correction. I'll upload the link. And please review the document that has the keywords and definitions. But remember that the only difference between what we're doing now and what we've done in the past, what you did in topic 3, what you did in topic 4, the only difference is that now we're able to analyze multiple constraints and multiple variables and come up with not only what is the maximum or minimum value, but make a choice between one or the other in alignment with that maximum or minimum value. Okay? Hello?
Right.
Cool beans.
Okay, and thank you guys for coming on today, and I'll get this squared away and get it reposted very shortly. So
I will, if can someone go in right now in the questions forum and ask where is the new link for the follow-up video? And then I can post that link in the class questions so that everybody has access to it.
Who's gonna do it?
Well, I got a message in here from Christina. I got a message in here from Kelly, so I know they know where it is.
Yeah.
And whoever feels like doing it would be great. Okay. Kelly,
I did it.
thank you.
You're welcome.
Star.
Okay, I don't see it.
I just did it. I said, please post the recording. And it says Zoom
Yeah.
recording.
Yeah, it's on opening. I see it.
It's on open.
Yeah, I don't see it yet.
Last questions.
No, I don't see it yet. All I see is what was
Here.
resolved. Wait.
It says-
Open. Got it. Okay. Got it. Thank you, Kelly. I was in the wrong link. Got
No
you.
problem.
All right. So give me about 10 minutes to redo this sheet and I will post that link right here. If anybody asks from your classmates, please refer them to class questions. I'll also post the same link in the announcement that was posted for this one. Okay? For those
Right.
people who you don't contact.
Roger that, sir. Thank you.
Got
All
it.
right. And take care, guys. Again, and I do want to tell you, and I'm not trying to use scare tactics, but the university is now reporting investigating a major event with us. Like I said, I had to take my laptop in and have them go through the whole laptop. And I don't know what settings they changed or didn't change or whatever, but it's been acting weirder since I got home. So just be careful when you open email. That's all I can tell you. This is not a pleasant thing. All right. We'll see you guys next week. If you have questions, feel free to post them to the class questions or send them to messages in Halo.
Roger that. Thank you, sir.
All right.
Thank you.
Thank
Welcome.
Have a good evening.
There you go.
You too.